Yeah, cool. So welcome on DataOps Poland. Alex, welcome. Stage is yours. I'm stop sharing now. Your turn.
All right, sounds great. Thank you, Tomasz. Let me get my stuff up. Hey, everybody. Great to see you. And thanks for having me. You know, I feel like after that introduction, I feel a little bit on enemy territory with more data engineering, data science, stuff like that. I know SQL is quite popular in that world. I actually come from that world. So my first tech job was in data engineering. I was doing a lot of Redshift, a lot of data pipelines, a lot of SQL, moving stuff around and things like that. So I have a lot of empathy for that world. I've since moved over to more DynamoDB and that sort of stuff. But I think there's good stuff to learn on both sides there. One thing I want to say up front is I tend to talk quickly. I apologize for that. I'm going to try and slow down a little bit today, especially since, you know, we've got some people maybe not in English as a first language. So I'll try with that. But biggest thing I would say is feel free to ask questions at any time. I have the chat window open and I'll kind of glance over there and see what we have, but I want to make sure this is useful for you all. You know, it's not for me, it's for you. So make sure you're getting the most out of that. And with that said, I'm gonna go ahead and get started. And again, ask questions throughout, but I'll also have time at the end, hopefully, to answer questions there. So, you know, today we're here to talk about DynamoDB. And Dynamo's been kind of interesting, Tomasz didn't show Dynamo on the DB engines ranking, but it's had a pretty good growth over the last couple of years as well. And I think one reason it's really been growing, and one reason I got into it originally, is because it's very serverless friendly, right? So you've had this explosion in sort of serverless architectures, especially if you're using AWS Lambda, tools like that. You had this like hyper ephemeral compute that's spinning up, spinning down, going around all over the place, that didn't work well with these SQL-based relational databases where you have this persistent connection, but maybe a smaller number, a limited number of them. That didn't work quite as well with how Lambda works as compared to containers or EC2 instances or anything like that. So you see, for that reason, a lot of people choosing DynamoDB in the serverless world, but also for other reasons, how well it works with infrastructure as code, how the permission systems work. It just feels very natural in that serverless world. And that's how I got into DynamoDB originally. But the more I sort of worked with Dynamo and things like that, I've come to appreciate the second reason that a lot of people choose Dynamo. And that's because you get consistent performance at really any scale and really truly enormous scales. And one thing I like to show is just a chart to compare sort of how relational databases and how DynamoDB tend to scale as you get bigger. So if we look at this chart here, on the x-axis, we have our data size. So how much data do we have in our database? As you go further out to the right on that x-axis, the amount of data is going to grow from 1 gig up to, a terabyte and beyond. On the y-axis there, we have performance. You can think of this similar to latency, right? So higher is worse. And at the beginning, it's blazing fast, and then it sort of gets slower and slower as you go up. Now, if you're working with a relational database, you often see a performance curve that looks something like this, right? And this isn't going to be totally accurate at a particular data size level, but the general curve is sort of correct, where it's going to get slower over time, right? So when you roll out that initial database and maybe you're either using it in test or in staging, or you've just rolled it out, there's not that much data in there, everything fits into memory, it's running great, users are happy and excited and all that. But then maybe you get 6 months, a year, 2 years down the line, you have a lot of data, you're starting to get complaints from users because it feels sluggish. You notice that it's sluggish as you're using it. You have to go investigate and say, hey, how am I going to optimize this? Do I need to increase my instance size? Do I need to add some more indexes? Do I need to denormalize? Like, what am I doing here to make this work? And at some point, you might get to a point where it's just like, hey, this is beyond the point of no return. We have to re-architect, just based on the amount of scale we have here. So that's what you're going to see with a relational database often, and you just sort of see that degradation over time and sort of that long-term, just a little bit of maintenance costs of going back and fixing it, optimizing it, things like that. To contrast that with DynamoDB, its performance curve is going to be more like this, right? It's going to be completely flat. So that means if you're running a workload in your test environment, in your staging environment locally, or you're doing it, 10 years into production with a terabyte of data, you should get pretty similar performance results in almost all cases with that sort of thing. So the nice thing about Dynamo, it gives you that consistency. The other thing I would say is, if you go look over on the far left side of that x-axis, there's going to be times when MySQL, Postgres, whatever is going to be faster just because they have that persistent connection. Maybe they've got it all in memory. It's going to be faster. I would say DynamoDB is fast enough in those cases, but it also gives you sort of that long-term maintenance cost, being a lot lower because you don't have to go back and sort of refactor on some of that stuff. So that's a big benefit of DynamoDB, is that consistent performance at any scale. And to do that, DynamoDB's had to make some, I would say, design choices and how they structure your data under the scenes, and also how they present it to you as a user. And one of those things that you'll see in the DynamoDB documentation highlighted here is you should maintain as few tables as possible in a DynamoDB application. So you often hear about single table design in DynamoDB. So we'll take a look at what that means here as we work through this and figure out what is single table design, what are some filtering strategies for DynamoDB as you're working with that. So what we're going to talk about here, data modeling with DynamoDB. Again, three main things we want to talk about. First, we'll just start off with the DynamoDB basics. We'll talk about some terminology, some concepts, just some things that you need to know to understand how it's all working. Second, we'll do something I call SQL, from SQL to NoSQL, right? So you're figuring out, hey, a lot of you likely familiar with relational databases with SQL. What are some of the trade-offs DynamoDB makes? Why does it make those trade-offs? And then what are the implications for you as a modeler of that data? And then finally, we'll go into some filtering strategies and just look at different ways to filter, because it is different than a relational database. Who am I? I'm Alex Debris. I wrote the DynamoDB book, which you can check out. I've also created DynamoDBguide.com, which is a free resource for working with DynamoDB. I'm an AWS data hero due to my work with Dynamo, and just an AWS and serverless fan. And as I was talking with Tomas before, I'm from Omaha, Nebraska, which is in the center of the US, but on my mom's side, my family is Polish. So I feel like I've got my brother in here, and excited to see you all. I mentioned the DynamoDB book. If you want to go check that out, you can go to DynamoDBbook.com. It's just a comprehensive guide to data modeling with DynamoDB. It's 450 pages. It's got 5 walkthrough examples, pretty in-depth ones. We model all of GitHub's backend. So if you want to do users and organizations and repos and issues and pull requests and comments and reactions and all that stuff, go check that out. Cool. So let's hop into it. Again, feel free to ask questions. I'm going to try and slow down as I go, but feel free to just tell me to slow down or go back as well. So let's start off with DynamoDB basics. And with Dynamo, I like to start off with 4 sort of vocabulary terms, right? So we have table, item, primary key, and attribute. I want to show these by way of an example. So let's get a few pieces of data here. Imagine you have like a users table in your application, right? And you can see I have 4 different users here. If you look at all that data together, that's going to be called a table. So similar in some ways to a table in a relational database, but also different in other ways, as we'll get into a little bit later. Now, if you want to look at an individual record, that's going to be called an item. So that'll be similar to a row in a relational database, or a document in MongoDB if you're familiar with Mongo. And that's going to be all those attributes together, right? Now, when you create your table, you have to specify what's called a primary key on your table. And every item you put into that table needs to include that primary key. It also needs to uniquely identify each item in your table. So you can't have 2 items that have the same primary key. That second one would just overwrite the first one. So you can see here on the left side of my table, I have my primary key. It's outlined in red there. For this, I'm using the username, right? Because it's likely that's going to be unique across all my users. I don't want to have 2 users with the same username. So I have the username here. In addition to that, I can have other attributes on my items. You can see here a first name, last name, email. These are going to be comparable to columns in a relational database, with the big difference being you don't have to specify these attributes up front like you would and declare your schema in a relational database. DynamoDB is going to be schemaless. So you're not going to declare that schema other than that primary key that we already talked about. And then everything else is going to be schemaless. This doesn't mean you shouldn't have a schema in your application somewhere, right? It needs to be in your application. You need to do validation validation, both when you're writing to DynamoDB and reading it back out from DynamoDB. But the database itself is not going to be doing that validation for you like it would in a relational database. So that's one thing. And you know, if I'm talking to data engineers here, that's going to, you know, if you're working with DynamoDB production applications, that could be something that's difficult for you, right? You're used to being able to pull out the data, pull out the schema, being nice and normalized. Not going to be the case as much with Dynamo, so you'll have to work around that as data engineers. I want to talk a little bit more about the primary key, because I mentioned it as one of the concepts, but it's really important and pretty crucial to how we work with Dynamo. We're going to see a lot of examples of that as we go. So when we're talking about the primary key, there are really two types of primary key. There's a table that has a simple primary key, which has just a partition key, or you can have a composite primary key, which has two elements, a partition key and a sort key. So if we go back to that example, you know, the example we already had, that was a simple primary key. It had one element, that username uniquely identifies every item in our table. You can also imagine using a composite primary key. You know, maybe we're grouping these users according to their employer. So here we have a primary key that has two elements, a partition key and the sort key. The partition key is employer, right? So that's saying who they work for. So me, myself, I have my company, Debris LLC, and then we have these folks that work for Amazon, Jeff Barr, Jeff Bezos, Werner Vogels, things like that. And then we also have that username as the sort key. If you look at this, you know, notice that a couple records here have the same partition key. That's okay. You know, the uniqueness requirement is a combination of those two elements for the primary key if you're using that composite primary key. So partition key and sort key, that combination needs to be unique. Also, you can see in the modeling software I'm using here, which is NoSQL Workbench, if I have a bunch of entities or items that have the same partition key, it's just going to group them together. So you can see that Amazon, it's all sort of merged together for those three items. And that's because that partition key is sort of a grouping concept in Dynamo and helps you think about that modeling. So don't get confused if you see that. Last thing I want to talk about is just like the API actions, right? So with Dynamo, rather than you know, writing out SQL strings, SQL statements like you would in a relational database, you're often going to be using direct APIs, just like you would any other AWS SDK call, right? So I like to sort of group the API into three different buckets. The first one I would call single item actions, and I call it single items actions because you're operating on a single specific item. So you're going out to a single item and doing something with that particular item. When you do that, you have to provide the entire primary key, right? Because you're identifying a single item. The way to do that is to use that primary key, which uniquely identifies each item in your table. Importantly, all of your write-based operations are going to be single item operations. So if you ever want to do a write, you have to use that single item action. You have to provide that entire primary key. And just an implication of that, you know, we don't have like an update where type of API or a delete where you can say, hey, here's the partition key, delete all the keys that have that partition key. No, you can't do that. You have to specify every single item if you want to delete it, if you want to update it, things like that. The second bucket of API action is the query action. And this is like a fetch many type operation. It allows you to fetch multiple items in a single request. When you're doing that, you must provide that partition key. And that's why that partition key is so important as we get going here. So if we go back to that table we had with that composite primary key, you can see I had a few items that had that same Amazon Inc. as their employer. And it's grouping those together and merging those cells together. And it's very easy for me to go to that and retrieve all of those items in a single request using that query operation. So query operation gives us a lot of flexibility because we can retrieve multiple items in a single request. Also, we don't have to know everything about the items that we're getting, right? If we're doing a single item action, I have to know both Amazon Inc. and I have to know the username, Raising the Bar, the Bezos, Werner Brothers, whatever it is. Whereas here I can just say, hey, give me all the employees that work for Amazon using that Amazon Inc. partition key, and it's going to return those back to me. So it gives me a lot of flexibility in querying and access patterns that way. So that's the second type of API action. The third one is going to be the scan, right? Which is going to be similar to a full table scan in your relational database, just a fetch all type operation when you're trying to get everything. You're going to use this pretty sparingly, right? Because it's just not a very efficient operation. Just like you don't use that scan operation in sort of your normal day-to-day access patterns in your relational database, you're not going to use it in DynamoDB because it's not going to be a very efficient operation. So those are the three buckets of actions. Just to get a sense of like how often you'll use each one, I generally say it breaks down something like this, where, you know, about 3/4 of your operations will be single item actions where you're inserting items, you're reading items, you're updating, you're deleting, whatever you're doing like that. Another quarter will be that query operation where you're reading lists of items to send back. And then a very small percentage, less than 1%, is going to be scan operations. All right, so that covers the just the basics of Dynamo. Again, feel free to ask questions, but I want to move into sort of SQL versus NoSQL. And the way I like to set this up is by talking about what I call DynamoDB's guiding principle. And this is not something that's written in their documentation anywhere or even shared in their marketing principles, but I think it underlies every product decision they make and every feature they leave out, everything. And that guiding principle is, hey, we do not want to allow operations that won't scale. So they're going to just, put you in a box and say, hey, you can't do that if it's not going to scale. And the reason for that, again, let's go back to that chart we were talking about where DynamoDB has that flat performance curve, no matter the size of the data, and I was sort of talking about this performance curve with that relational database, how it gets slower over time. And that's true in some sense, but it's also not true because you can model your relational data in a way that shards well, that scales very efficiently. Maybe you're avoiding some of the actions that don't scale, and you can get a performance curve like DynamoDB. But the thing about Dynamo is it basically forces you to do that. It's not even going to allow you to do something that won't scale, right? They're going to put you in a box and say you can't do that. So that was sort of their end goal, right? Let's make sure we build a database that you can't sort of not scale. So what are the choices they made to make that happen? Number one, the importance of the primary keys, right? So we talked before when we were looking about how important your primary key is. Almost all of your data access is going to be off of those primary keys. So it's very easy for me to go to this table and say, hey, give me Alex Debris that works for Debris LLC. I can get that very easily. Or I can say, hey, give me all the employees that work for Amazon Inc. But it's not as efficient for me to query off one of these attributes. And that's why we're not going to query by those. I couldn't go to this and say, hey, give me all the employees whose first name is Jeff, or give me this particular email address and fetch it to me. As this table is structured, it's not going to be efficient for those. We want to be working off those primary keys. And let's talk a little bit about, the computer science underlying that, and how that all works. And Philip, I see your question. I'll get to that in just a second. So if we think about how DynamoDB works, you're going to be connecting to DynamoDB as a service, and you might think it's this giant supercomputer, but it's not. What they're doing is they're just splitting that across multiple nodes behind the scenes called partitions, right? So your data is going to be split across all these different partitions. Each partition is going to hold up to about 10 gigs of data. So you can see here, I have partition 1, partition 2, 2 partitions. Maybe I have 15 to 20 gigs of data in this particular case, and Dynamo is handling that for me. Now, when a request comes into DynamoDB, let's say I want to do a put item, which is going to insert a new record into Dynamo, and I'm saying, hey, let's put Andy Jassy in here. It says the employer is Amazon Inc. Username is Andy Jassy. That DynamoDB front end, it's going to take that value and it's going to hash that employer value, which is our partition key in this sense, right? So it's going to take that Amazon Inc., it's going to hash it, and it's going to say, okay, based on that hash, that item belongs to partition 1, right? So immediately based on that hash, it knows which partition it belongs to. And the great thing about this is, you can add a third partition, you could add 6 more partitions, you could add 1,000 more partitions. And that operation there where you're hashing the value and figuring out to which partition it belongs, that remains a constant time O1 operation, right? So immediately you're able to get down to this partition, which holds at most 10 gigs of data. So, if you have a table that's 2 terabytes or something like that, the first thing you do, milliseconds after you get there is going to be figuring out which partition it goes to and going to that partition. So you're not searching across this giant lake of data. So that's why that primary key and especially that partition key are so important, right? And that's what gives you that consistent performance. Rather than playing around in 2 terabytes of data, you're always playing around in that 10 gigs of data. So that's why the primary keys are so important. Just going to stop for a second. Philippe had a question about how DynamoDB stores data under the hood. Like, are they using Avro, Thrift, Probuff, something like that? Basically, you don't know. Like, they probably have some compression format and storage format that they're using, some binary format that's pretty efficient, but you don't really know about that. You interact with it more like a service than as like a direct access to that file storage, right? So you're going to interact with it as you know, the HTTP response that you're going to get back to them and things like that. So when you're writing data to Dynamo, you do specify the data type. So if you have an attribute, it can be a string attribute, it can be a number attribute, it can be binary, it can also be complex attributes like lists, maps, things like that. But in terms of the actual storage format in disk, it's not really apparent to you. Good question. Yeah. So we talked about the importance of, you know, primary keys as one of the choices that DynamoDB makes, right? That primary key is very important. All your access patterns are going to happen on that primary key so that they can use that partition key to figure out how this stuff works. A second choice they made is you know, they remove some features that have difficulty scaling well, you know, in relational databases. So you won't see joins, you won't see aggregations. The big thing about these is these are basically unbounded operations, right? You don't, like, when you issue that request, you don't know how many records it's going to go across, right? You can do an aggregation like select count star where some condition, and that could hit 5 rows, that could hit 1,000,000 rows, that could hit 1,000,000,000 rows. You don't really know when you do that. Because that's unbounded, because they want to give you that consistent performance, they're saying, hey, you can't do that sort of stuff. If you want to have joins, if you want to have aggregations, you need to think about that as part of your modeling and do it in a way that scales rather than sort of relying on the database to do that, but giving you some unpredictable performance down the line. Another question from Surrender Meta. So partitions, should we hash them? Does DynamoDB do it automatically? You know, when I'm talking about partitions, it's more of just like a helpful way to build your mental model. DynamoDB doesn't actually expose those partitions for you. So you don't know how many partitions you have. You don't know the hashing function that assigns your item to different things, anything like that. You don't have to worry about that hashing at all. DynamoDB is going to do that for you. The big reason they're hashing that is just to give you, you know, just to spread out that data. So if you have some contiguous records that happen to have partition keys near each other that are accessed in similar ways, they'll at least like split that out across different partitions. But that hash stuff is not available to you at all. Yeah, a good question. All right, so now, you know, we know primary keys are very important. We don't have joins, we don't have aggregations. This feels very different from a relational database, right? What are the implications of that because of these choices that they've made? The first one is, you know, there's a feature called secondary indexes that are very useful and that you'll use a lot in your data. So we talked a little bit ago about how your primary key is very important. You can query with that primary key. You can't query with those other attributes. But what if you do want to query with those other attributes, right? What if you have different access patterns? Maybe sometimes I want to get these people by their employer, but sometimes I want to get them by their email, right? I have different access patterns on the same items. What you can do is you can set up what's called a secondary index on different attributes in your table. And what they're going to do is, you know, it's basically a copy of your data with a new primary key that allows you to make reads from that secondary index, right? So here I could set up a secondary index on email. And now if I look at what my secondary index, it looks like here, right? It's all the same data, but now it's keyed by something else. It's keyed by email rather than employer and username, so I can quickly and efficiently get those items. So secondary indexes are going to be very important for you. What's going on there is data from your base table is going to get copied into that secondary index with a new primary key. So it's basically like they're just maintaining a copy of your data for you in a reorganized format that works with that partition key format there. Now you can use query or scan, so the read-based operations on that secondary index, but you can't do writes directly to your secondary index. All the writes have to go through your base main table there, and then they get replicated out to your secondary index in a read-only mode. Let's see, question here. So Dynamo does partitioning for us. Can we do some repartitioning or specified partitions, anything like that? Just, you know, if we know some performance stuff there. No, you cannot repartition data at all. But the big performance problem, like, you're basically not going to see a slowdown from like a big partition that much or anything like that, just because of some of the limits they've set up around Dynamo. We're not going to get into that deeply, but basically, like, one limit they have is if you do a query operation, you can get a max of 1 meg of results back, and then, you know, they'll give you a pagination token. You can go back and get more. So that's a way for them to bind how much, like what that performance lag is or degradation is going to be like. It might get a little slower just because you're sending more data back over the wire, but it's not going to get significantly slower because you have now 1 billion or 2 billion rows that you're trying to fetch. So really thinking about that partition key, which that partition key is in your control. And then because of that, you have control over that stuff. But in terms of like the actual underlying partitions, you don't have access to how that works. Another thing Dynamo does, just, I mentioned the one megabyte limit on read requests. Dynamo does have like really strict limits on how many requests per second you can do to a specific partition, which you should think of as your an item with a partition key in that sense. And basically, they're going to limit the number of requests you can hit with any one partition per second. And that, again, helps prevent that degradation, right? So you're not just hammering this one thing and it's getting overloaded with requests. They're going to say, hey, here's our physical limit. They're going to set that limit a little below that so that they don't have performance degradation issues based on someone just hammering a particular partition. So if that's going to be an issue for you, then there are some strategies to work around that. But again, it's something you're planning for up front rather than hopefully finding out later. All right, cool. So getting back to implications, great questions. Keep them coming if you have them. The second implication when you're working with Dynamo is you want to know your access patterns in advance. With a relational database, I'd say actually both with a relational database and DynamoDB, you'll make your ERD, right, your entity relationship diagram, and show how those entities relate to each other. But then in a relational database, you often take that ERD, you ship it directly to your database, and you model based on sort of that stuff, and then you set up your queries once you've normalized your data. But when you have that ERD with Dynamo, you don't want to just ship those directly to your DynamoDB tables. You want to actually think about your access patterns, actually list out your access patterns specifically, and get very specific on how you're going to accomplish those particular access patterns given the primary key structure you use. So you're really using that primary key structure to drive your access patterns. And a great question here from Surinder. So I said you can't update secondary index, but it lets us create new partition keys. So what happens in that case? So I probably wasn't clear on that. You can't update a secondary index directly. So you can't go to a secondary index and do an update item or a delete item on that secondary index. You can only do that in your base table, and that gets replicated out. But if you make a change to your base table to a key element that's used in your secondary index, right? Like, so if I change someone's email, I was showing how I index that email. If I change that email, they would manage that in your secondary index where they would delete the old record and put in a new record with that new primary key, with that new email value that you've given. So you can make changes that are reflected in your secondary index. You just can't make writes directly against your secondary index. And the biggest implication about that is you really need to think about your primary key of your main table when you're doing your write-based access patterns, because remember, all your writes have to be single item actions. They have to go through your main table. So you need to sort of accomplish it that way. All right, going back to implications. So we talked about knowing your access patterns in advance. We'll get to the third one, and this is what really throws people, and they see this design out there and they're like, what's going on? But often you see all items in a single table and using generic attributes for the primary key. So the examples I've done before, the tables I've shown have looked kind of relational, right? Everything's got the same values. The values sort of make sense everywhere. But let's get into the single table design stuff and see how that changes the game. So I want to walk through an example. Imagine we have a SaaS application, right? So we're creating something and other people can sign up and use it. We have two entities that we want to model. We want to model organizations and we want to model users, right? So organizations sign up for your SaaS application. They're the ones that pay the bill. And then users, belong to organizations that can act on behalf of that organization within your SaaS application. So let's get started there. Let's look at this table here. And I've put two items into this table. You can see right there, I have Berkshire Hathaway and I have Facebook. A couple things I want to call out here, right? So let's look at the primary key. And you'll notice that the partition key and the sort key names are very generic, right? Rather than using something like organization name, username, subscription level, something like that, I'm using these generic names like PK and SK. PK for partition key and SK for sort key. Now, the reason I'm doing that is because I'm putting multiple items of different types in here. So they're going to have different values, right? Not everyone's going to have a username or an org name or things like that. So I'm using these generic values. or generic names, excuse me. If you look at the values themselves, they're also kind of weird, right? You're concatenating different values together. You can see I have, for these organization items, they start with org hash, and then they have the organization name. Part of that is to help identify what type of item it is. Part of it is to prevent overwrites across entities of different types that might have similar values there. Part of it could be for ordering, but often you're going to have these sort of concatenated, sort of weird values for your primary keys there. So we have our 2 organization items in there. Let's add a couple user items into our table. So I still have those organization items here, but now I've added 3 user items. You can see outlined in red here. So I have Charlie Munger and Warren Buffett working for Berkshire. I have Sheryl Sandberg working for Facebook there. A couple things to note here, just look at the primary key patterns. Notice how they're different for those users, right? That SK is user hash and then all caps the username, right? So it's different than that organization value, although it does have the same partition key as its parent organization. We'll talk about that in a second. If you also look at the attributes we have there, notice that the attributes are different for users than they are for organizations, right? Organizations have org name, they have subscription level on there, whereas the users have username, they have role on there, right? Because different attributes apply differently to different entities. That's where that schemaless nature of DynamoDB can come in handy. So that's, that's one of the big implications that starts to throw people when you talk about single table design and getting those generic attributes out there. The other thing I would say, and this could be tough for you data engineers out there, but get comfortable with denormalization in some of this stuff. You're gonna, I love normalization. I think it's a great thing, but also think about where you can relax it, especially as you're giving up joins, you're giving up aggregations, you're giving up different things. Where do you need to relax normalization to make your data access patterns easier, and where it makes sense? Maybe you don't have the downsides of denormalization there. So one example I like to show is if we go back to that SaaS application, right? We have organizations, we have users. Let's add another relationship in there and say, hey, an organization is going to have payment methods, right? They need some way to pay. Maybe we allow them multiple different ways to pay, and they can store that on them. We could store those as different entities entirely, but every time we access those payment methods, it's going to be within the context of that organization. So what we might do instead is something like this. I've added these attributes in red. That's all that's changed here. But on these organization items, I've added this payment method attribute, and this is a map attribute. So it's a complex attribute. It's not just like a string or a number or binary or something like that, but it's a map, right? Like in your programming language. And I'm holding multiple different types of payment plans. I have the default one, which maybe is a credit card. I have a backup, which is a bank account, something like that. But they can register a few different accounts here. And there are different ways that denormalization comes into effect. It could be something like this. It could also be duplicating data across a couple different items. You have to be just comfortable with relaxing some of the assumptions and patterns you have in a relational database. And again, not saying that those are bad. I know I have a lot of relational fans here, of which I am one. But when you're working with Dynamo, you want that consistent pattern. You need to think about this and some of the trade-offs that you'll get in with there. So you get comfortable with denormalization. You also might, assemble collections of different types of items, or maybe even, the same type of items, but related items as needed. So, I often call this pre-joining your data. But if we go back to what we have here, our SaaS application that has organizations and users in it, you can see I have a couple items here that all have the same partition key. They have that org Berkshire partition. Remember that I can query those very easily in one request. I can fetch all those records in a single request using the query, using that partition key. So that's gonna be called an item collection. Whenever you have multiple items that share the same partition key, it's gonna be an item collection. And remember, if we go back to that partitioning concept we had before, how there's that important part where all items with the same partition key will be near each other. It's very efficient to get those, right? So we have here that Amazon item, but you could also imagine a query for that org hash Berkshire partition key that we were talking about. Very quickly, I can say, hey, those items are located on partition 3. You can go to partition 3 and find those items very quickly for me. So item collections, very efficient to work with in DynamoDB, and you might use those strategically, right? So look at this. I have an organization item. I also have user items in the same item collection there. And what this allows me to do is pre-join my data if I need it, right? So imagine I have an access pattern where I need to list all the users for a particular organization. But when I'm satisfying that access pattern, maybe I need some information about that parent organization as well, maybe the subscription level or just different things like that. What I can do is pre-join those into the same item collection. So then when I hit my DynamoDB table, it's only doing one read. It's hitting all the items in that partition, getting them back to me and sending it back very efficiently. Any questions on sort of some of the implications there? And then we'll get into some filtering concepts.
Seems no.
Cool, sounds good. So let's talk about filtering strategies. We've got about 18 minutes left, and I at least want to leave some time for questions. So I'll probably go 8 to 10 minutes here. So I might skip some of the more advanced ones, but we'll just see how far we get, right? So let's talk filtering with DynamoDB. If you're used to SQL, if you're used to a relational database, you might be used to something like this, right? Some sort of select query. Most importantly, you have this really magical where clause at the end where you can do sort of all sorts of conditions on the data you're seeking. You can filter on some sort of column, you can filter on a joined column, you can filter, using the current time, you can filter all sorts of ways with relational database. But Dynamo is not going to be nearly that flexible about how you filter stuff. You need to be more specific, more intentional in advance about how you're going to filter your data with DynamoDB. So the key thing to remember here, almost all that filtering is going to happen with your primary keys in DynamoDB. This can happen in a couple different ways, and I just want to walk through some of those strategies, right? So we talked about how you're querying with that primary key, not with the attributes. So the strategies here, the most common one is going to be filtering with that partition key. So in this case, we talked about how that partition key is very important. They're going to hash that value, locate them all together. And that's going to be that O1 operation. It's going to be a hash table lookup there to do that sort of thing. So the great thing here is, imagine I'm running IMDb or some sort of movie website. Someone clicks on Tom Hanks. They want to get all of Tom Hanks's movies. Bam, I can use that partition key to do that. I can get that query really quickly, say, hey, give me all of Tom Hanks's movies and do that. And then what I'm doing is I'm filtering down to Tom Hanks's movies, excluding out any other movies, right? So partition key, that's going to be a very common one that you're going to be filtering with. You can also do filtering with a sort key. So when you're talking about the sort key in DynamoDB, remember that composite primary key has a partition key and a sort key. I mentioned that all items with the same partition key are going to be located near each other on that same partition. Well, within that partition, within that item collection, items are going to be sorted according to that sort key, right? So what you can do is sort of structure those in a way that help you satisfy what you need. So let's talk about filtering with the sort key. And one other thing I should say is if you're doing a query operation with Dynamo, you have to include that partition key in your query, but you can also have conditions on that sort key to filter out some things and include some things, exclude other things, different things like that. So two patterns we have with the sort key, sometimes the sort key itself has meaning, right? So let's look at this example here. This is an IoT example. Imagine you have sensors that are out in all these different places, and each sensor is sort of sending back readings over time. It's associated with a timestamp, right? So in this case, what we have is the partition key is that sensor ID. The sort key is that timestamp. In this case, that timestamp has meaning, right? It's very easy for me to say, hey, give me all the readings for for sensor 14891 from the 15th at 1 minute to 2 minutes, right? So I can filter down to the exact readings I want between these two particular times. So that sort key itself has meaning. The second one is the sort key has meaning based on how you've modeled it, right? You've sort of created this sort key, this Franken sort key to combine these items in different ways. This is a more complex one, but this is an example I have in the DynamoDB book showing how to model GitHub's backend, right? And we talked about pre-joining items here, but if you look here, I have all these items in the same item collection. And I have first some issue items. So imagine some issues in a GitHub repo, right? Those are outlined in green at the top. Then in the middle there, I have that repository item, the parent repository for those issues. And then also I have some star items to keep track of who has starred this particular repository. And I'm keeping all those in the same item collection. And what I might do is I might have different access patterns where I want to get different groupings of them, right? So maybe I have one where I want to get the repo and all the repo's issues, right? So I can do that using conditions on that sort key to say, hey, start at that repo item and fetch everything that happens before that. It gives me that repo, gives me the issues. I've pre-joined that data just like we were talking about with organizations and users before. Or alternatively, maybe I want to get all the stargazers, right? So I say, hey, give me the repo item and all the stargazers, fetch all those in one request and return those back to me. So what I'm doing is putting conditions on that sort key to allow me to filter down to exactly what I want. All right, next strategy is you can use what's called a composite sort key. So I talked before about a composite primary key, but you can even encode multiple values into your sort key to allow some filtering that way, right? So the situation here is maybe you want to filter on multiple attributes in a particular access pattern. So imagine you have like an e-commerce store and your primary key is customer ID and order ID. You have these other attributes like amount, order status, order date. You have an access pattern now where maybe people want to filter through their orders. They want to look at them by time, but they also want to filter based on the order status, right? I want to look at all my orders that have been delivered, all my orders that haven't been delivered, all the ones that have been canceled, things like that, right? So what I can do is I can make sort of a combo attribute here. So you can, order status and order date. I can jam those together. So you see my order status, my order date, and then I have this order status date, right? Which is the order status, a pound sign, and then the order date that allows me to filter into those. Then if I set that up as a secondary index here, you can see that sort key is order status date and allows me to filter on that order status date to say, hey, I want everything that's canceled, but only in this sort of time range to get all that back, give that back to me, right? So it allows me to filter based on two conditions, both the status and the date. So the big thing here, I mentioned you want to filter on multiple attributes, the order status and the date. The big key is that all or all but one of the attributes have to be enum-like values. And that's because when you're filtering based on that sort key, they're going to be sorted alphabetically. So you sort of have to filter left to right if you want to do that stuff. So if you have multiple values, you basically have to have exact match on the early values, and maybe you can have the last value be a range query type of thing. But so we have it set up like this. Imagine if you did it the other way where you did status date order. So you put the date first and then put the order status, right? So I put that date first. But now if you look at what that looks like in the sort key, it's ordered by that date first. I can't really filter down based on that actual order status. All right, a couple questions here. Philippe, not sure if it's been mentioned, but how many key levels can we go? So we talked about primary, secondary. Can we have 10 or 20 key levels? So I'm not sure if you're talking about the primary key where it has partition key and sort key. In that way, you can only have those two elements, partition key and sort key. But if you want to have secondary indexes, you can have multiple secondary indexes on the same table. So you can have your main table that has your main primary key, all your writes go through that, but then you can have like 20 different secondary indexes. Often you don't, often you have, 3 to 6, something like that. But you can have multiple secondary indexes that are different reflections, different shapings of your data for that. And then Philippe says, how can we query issues with open status? Because we are not able to query only by status. This has to be handled by the customer application. So I believe this goes back to the GitHub example we had before, where the issues were there, but some were open, some were closed. And it actually kind of ties into the second one, the composite sort key there. If you want to do something like that, you would have to have a secondary index probably where that sort key was maybe status and then issue number. And that would allow you to filter down based on the status and get the related items there. And actually, I cover that pattern in my book if you want to take a look at that one. So we're going to keep zooming along. I know it's fast here, but I want to make sure we have time for questions at the very end. The next pattern is called sparse index. This is one of my favorite ones, right? So when you set up a secondary index, only items that have all elements of the primary key for that secondary index are going to be copied over, right? So you're going to create that secondary index. You're going to say, hey, here's the primary key for my secondary index. If you don't, if you put an item into your table that doesn't have one or both of those elements, it's not going to be put into your secondary index. You can actually use this as a way to filter things out. So a couple strategies we'll look at here. First, you can filter within an entity type based on a condition. So let's go back to that SaaS example we had before. We had organizations, we have users. You can see on the users, they have a role, right? They have members or admins. Imagine I wanted to get all the admins for a particular organization. I could fetch all the users and filter out the ones that aren't admins, but if I have a bunch of items, that might not be efficient. So I could do that in a secondary index. I've added these values here on the right, and you can see these are GSI1 PK, GSI1 SK. Again, this is sort of like the PK and SK we have before, but this is for a secondary index. So you'll often see GSI, Global Secondary Index. That's what that stands for. And then 1, the number of your secondary index, and then PK and SK. So same pattern we were using for PK and SK, but applied to a global secondary index. Now, if you look at these values here, what I have is for every user item that is an admin, I've given them that GSI1 PK, GSI1 SK value. And I've partitioned it by that that organization name, so they'll be all grouped together. It has a sort key of admin. The other thing I would say is, just looking at this, if you have someone who's just a member who's not an admin, they're not going to get those values. So they're not going to be included into that secondary index. The other thing I would say is when you're doing this pattern, you can index other items in different ways. So I also have an indexing pattern for organizations. You can overload your secondary indexes just like you overload your main primary key. So now if I go look at the secondary index and what it looks like, right, I can go to Berkshire Hathaway and say, hey, give me all the admins. And here I have Warren Buffett, but I don't have Charlie Munger, right? So I filtered out within that entity, within that user entity, the items that I don't want, the member entities, so I can get just the admin entities. Another question from Surrender. The partition key is user readable. Should it be hashed? You don't have to hash the values that are going to DynamoDB. Dynamo is going to hash them for you and use that to distribute your data. So you don't really need to think about that. So as far as you're concerned, as you're using Dynamo as a service, yeah, they can be user readable stuff. All right, second strategy I want to talk about with sparse indexes. Sometimes you want to project a single type of entity into a secondary index. So here I have an example, and maybe this is like an e-commerce store, and you can see I have different types of items here. I have customers. The first 2 items are customers. Then I have a couple of orders that these customers made. Then I have some inventory, just tracking all the items in my store. And you can imagine the marketing department comes to you and says, hey, once a week, we want to get all the customers and send them a coupon. How can we do that sort of thing? And you say, well, now I have to scan my entire table to do that. And I'm gonna have to look at a lot of orders and a lot of inventory and all this different stuff. It's kind of a wasteful operation. But what you could do is you can add an attribute just to those customer items. Maybe you call it customer index ID or whatever you want to call it. You set up a secondary index on that value. And now if you look at your secondary index, the only items that are copied into that are the ones that have customer index ID, which are the customers, right? So now that secondary index has only customers in it. And now you can scan just that, and your customers will be there very efficiently for you to access, and you don't have to worry about filtering through orders and inventory and all that different stuff. So that's the second pattern with sparse indexes around filtering, an entity type, right? You just want to get customers. You don't want to get orders. You don't want to get inventory, things like that. I think I'm going to stop here, even though I have a few other ones because they're pretty obscure. But yeah, any questions I can answer for folks? I'll stop sharing so you can actually see my face if you want to. But yeah, any questions I can answer for folks? Great questions coming in here. I know this is a lot to take on too if you're coming from a relational world, but hopefully it gives you a flavor of Dynamo.
Yeah, I'm not sure if you answered this question about the partition key. Is user readable? So this rehash it.
Yeah, I got that one. So that one, yeah, you don't have to think about it from a user perspective. Dynamo is going to be the one doing that hashing. As soon as it hits that DynamoDB front end, the request router, it's gonna hash and distribute that.
Cool. So if I understand correctly, so now is the open discussion, right? Or you have extra slides?
Yeah.
Okay, so don't be so shy. There is a button, unmute yourself. If you can unmute or have a background noises, just let us know and write on the chat. But I will ask a question from my side about the prices, because everything has price in this market. So how it looks, I mean, it's...
Yeah, so DynamoDB, I think, has a really interesting pricing strategy in that you're not going to pay for resources, right? You're not paying for instances that have CPU, that have RAM, that have disk, and you have to sort of figure that stuff out. what they price you on is the amount of data you access directly. So you have two axes. One is read capacity units, one is write capacity units. And they basically give you the ability to write or read that much data, right? So a write capacity unit says, hey, for every 1 kilobyte of data you use, that's going to use up 1 write capacity unit. Read capacity is for every 4 kilobytes of data you read, that's going to be 1 read capacity unit. So it's a very tight connection between usage and value. It also makes it a lot easier to estimate your costs, right? If you have a decent sense of how big your items are and how many requests per second you're going to handle, you can estimate that out and say, okay, this is about what it should cost us, and at least be in the ballpark. Where for me, I found like with capacity planning and relational databases in the past, it's hard to get a real good look at, hey, is this instance size big enough? Often you sort of over provision your instance size, you get out to production, you have way too much in stuff there or not enough. You got to scale it up, and it's hard to get a sense of that stuff. Whereas Dynamo, you're sort of paying for those resources directly. You can also over provision at first and then scale back down if you need to very easily. You can scale down a couple, like multiple times per day if you need to, scale up and down, lots of different things like that. So a lot more flexible in terms of like, is it going to be cheaper or more expensive? You know, it depends a lot on your access patterns, but I think for a lot of people, especially people that have single digit, utilization on their relational database, because it's hard to capacity plan, it's going to be a lot cheaper in that sense. There's some places where relational database might be cheaper, some where Dynamo might be cheaper. It all sort of depends on the access patterns.
Cool. And I know it's maybe a silly question, but example, it's a little bit vendor locking, right? Because it's available, only in Amazon, right? So
yep.
If I use
absolutely.
Cloud provider, it's almost doesn't make sense to use it because of the latency and all the stuff, right?
Yeah, sure thing. So that's one thing with Dynamo is like it is only provided by Amazon, although, as you have next week, there is the open source alternator API. So if you wanted to move to Cassandra or Scylla, you could use that with the DynamoDB API on top. So that's absolutely true. I would say the nice thing, like it's true you have some lock-in, but also Dynamo, because they totally control it and control the infrastructure and everything behind it, they can give you a lot of nice things around scalability, around performance guarantees, around scaling capacity up and down throughout the day as you need to. Whereas like if that was more of just like a more infrastructure product that was widely available, it'd be a little harder to do that. I think you don't see many databases offering those sort of things just because it's hard to do for sort of open source stuff.
Okay, so now the question from David. Could you please tell us a little bit about backup DynamoDB?
Yeah, sure.
And then Philip, you can unmute yourself and ask the question directly right after that.
Cool. So David, DynamoDB backups, there are basically two kinds of backups they have. One is like a manual snapshot backup. You can just trigger it anytime. You can set up some sort of schedule to do that if you want to, using whatever the backup manager type thing is. So that's good if you have like regulatory requirements and you need to say, hey, here's my backup 6 months ago, here's my backup 3 months ago, 1 year ago, things like that. You can also enable something called point in time recovery, which is just like always backing up your data as it goes. And it allows you to recover your database to any second in the last 31 days. So if you screw up something in your data, you can always just roll it back a day, 2 days, 4 hours, whatever you need to do, and say, hey, I want this exact second is what I want to restore it from. So I usually recommend that. That's just like an easier one. You don't have to think about maintaining backups, things like that. But I would say making the backup itself it's basically instantaneous, right? They're just going to snapshot the disk or whatever somewhere else and throw it in S3 for you. Restoring a table from a backup can take some time just because, they got to write a lot of data from, S3 into actual tables. So that can take a little bit of time, but that's how restores are generally.